Okay, welcome back. Today we're going to be looking at product to sum identities. This time we're going to do things a little bit differently. Rather than just showing and proving an identity, we're going to kind of discover an identity. Now if we consider the following two expressions, the cosine alpha minus beta, cosine alpha plus beta, those two identities, the angle sum and difference identities for cosine, are very similar. And some kind of interesting things happen if we start to play around with those. So we see now, if we look at what we have there, cosine alpha, cosine beta, sine alpha, sine beta, no problem. Cosine alpha, cosine beta, minus sine alpha, sine beta, again, no problem. Notice the sine alphas are opposites, and they go away. And then notice that the stuff that remains, the cosine alpha, cosine beta, cosine alpha, cosine beta, that those things are the same. So we can combine those and say that we have two cosine alpha, cosine beta. At this point in time you're probably thinking, so what? Well, consider another thing. If you took half of that, you would get cosine alpha times cosine beta. But hang on just one moment. The 2 cosine alpha cosine beta, that was equal to the cosine alpha minus beta plus cosine alpha plus beta. Right? They're equal. So we can actually say that cosine alpha cosine beta, the result that we got, is actually equal to not cosine alpha minus beta plus cosine alpha plus beta, but half of that thing. And now what we've established is the identity. This thing is a product to sum identity. It takes a product and it turns it into an identity. Now that's just one of them. There's a couple of others. That's kind of how these things get uncovered. What we're going to look at now is how we can go from actually establishing an identity now. So we're going to look at another one of these product to sum identities and show you how to go about actually proving it. And basically the proof is the same really as our discovery. So now that we have established one of the identities, let's look at it now from the point of view of actually proving an identity. So in other words, we want to show that sine alpha cosine beta is actually equal to 1/2 sine alpha plus beta plus sine alpha minus beta. Well, as we typically do with identities, we want to start with the more complicated side. In this case, the right-hand side there. So we begin with that identity, that side of the identity, and we know what sine alpha plus beta is. We know what sine alpha minus beta is. So we go ahead and we start to expand those out. Now at this point you may want to stop the video and see if you can work that out. All we've done at this point is use the identity for sine alpha plus beta and the identity for sine alpha minus beta. And see if you can follow that problem through to completion. Okay, hopefully you got the answer. If not, let's continue. You'll notice, much like the problem we just did, that we have some things that will cancel out, specifically those two guys. And we also have some things that will combine, particularly those two. So we can now say that we have 1/2 of 2 sine alpha cosine beta, but 1/2 of 2 is just sine alpha cosine beta, which is what we wanted to show. Okay, don't stop things yet, because now is your problem. This is a problem for you to turn in class. I've shown you one identity, I've now shown you proved another identity. So this is your problem to turn in. That is to show that sine alpha, sine beta, is equal to 1/2 cosine alpha minus cosine alpha minus beta minus cosine alpha plus beta. And you can turn that in class. Hopefully this helps you out as you work with these product to sum formulas. They're very straightforward as long as you remember your angle, sum, and difference formulas. But really the key, that and kind of keeping your head about you and not like, oh my goodness, what is that thing? Alright, till next time.